There's no better leader and advocate of additive manufacturing than our keynote speaker, Dave Burns of the X1 company. A group of us met with Dave last night, and I'm just absolutely thrilled that he chose Baltimore to come to talk with us about additive manufacturing on our launch of this exploration. Dave will educate us on the transformative qualities of additive manufacturing. He will inspire us to see his vision. He will help you to understand that additive manufacturing is a disruptive technology that redefines manufacturing in some fundamental systemic ways. It will bring back manufacturing through innovation that transforms the processes and creates new rules of engagements. So folks, please join me in welcoming a good friend, David Burns, a visionary transformational leader, as he leads us on our journey today. And Dave's going to speak from the floor. Dave?
Thank you, Mike. Can everybody hear me okay? Good place to start. Well, I appreciate the introduction, although it's actually sort of daunting because the notion that I'm actually most of that is sort of overwhelming to me. I really am grateful for the chance to be here and honored to have the opportunity to speak to you. I did meet with a small group of people last night, and quite honestly, the Baltimore community is fortunate to have such a group of passionate, visionary people who want to make this community a better place. And so, from my perspective, RMI is great, and you're really lucky to have people who are this actively involved in your community. So, thank you for the invitation. As I told Mike, I'm really honored, actually, to have the chance to speak to you. I've been involved in manufacturing now for my entire work career, which spans about, I think, 34 years this year. And so I know a lot about making parts, and I tend to know a lot about manufacturing technology, but I struggled a bit to try to understand what I might say to you that you would find important, because what I think is important maybe isn't important to you. And what I'm going to do actually is I'm going to keep my remarks relatively brief. Hopefully I'll say something along the line that you'll find stimulating, and we'll have a good chance for a question and answer exchange when I'm done. And I pondered this question of what should I say to you? And I actually thought about it for weeks and weeks. And I finally came up with a title for this presentation, which I'll share with you in a minute. And I travel a lot for work, and I was on a plane the other day, and the flight attendant said, as I was sitting down in my seat, this is an announcement. This plane's going to Minneapolis. If you don't want to go to Minneapolis, this would be a really good moment to get off the plane. So let me ask you two questions. First one, are you interested in manufacturing? And the second one, do you believe that the US has a manufacturing problem? If your answer to either of those questions is yes, then fasten your seatbelts and put your tray table in an upright and locked position. If your answer to both those questions is no, then this would be a really good moment to wander out and get a cup of coffee for about 30 minutes or so. Although I need to tell you, if you do that, actually I'm going to sort of point to you and make sure everybody notices as you leave. Okay. Manufacturing technology is a technology grouping of companies that provide products to others to make stuff. It really is as simple as that. In the US, it started out basically as the machine tool business, but since then it's evolved to people who make machines, who make inspection devices, who make robotics, and nowadays also make, as you see in the upper right-hand corner, additive manufacturing equipment. So manufacturing technology is this grouping of products that support people who make stuff. And this is what I've done my entire life. For 27 years, I worked at and eventually ran a company in New York that was a machine tool company, one of the most successful in the world. And it was a great career, and I enjoyed it, and I learned a lot about the world, and I learned a lot about manufacturing during that time. I left in 2005, and I was sort of convinced I wasn't going to do that anymore because it's a tough business. But along came a friend of mine who said, I'm starting a company down in Pittsburgh called X1, and we're going to do additive manufacturing. And I studied it and I thought about it, and I decided at that moment in time that what additive manufacturing was going to provide to the world eventually was so transformational and so disruptive, and it was going to be so active in breaking the paradigms that we understood about manufacturing that I really wanted to be part of it. So after pondering it for a while, I thought, I want to be part of this. So we started X1 Company. And I learned about the technology, I got excited about it, and I became a disciple of additive manufacturing. And for years, I traipsed around the country, accosting individuals and saying, I want to talk to you about this amazing thing, it changes everything. And do you know how when you're talking to somebody who maybe dated your daughter or borrowed your weed trimmer, you know, and so they owe you the courtesy of listening to you, but the eyes glaze over, and it's like, okay, get done with this pretty soon. For a long time, that's sort of the way it was. And I don't know what happened, but about a year ago, somebody flipped a switch. And we went from not being able to find anybody to talk to about this thing we called additive manufacturing to suddenly everybody was talking about additive manufacturing. Call it the Industrial Revolution 2.0. That's out of the New York Times a few months ago. I can't think of another technology that has so many implications for new industry. That's out of Forbes magazine 4 weeks ago. As the technology evolves and becomes ever more accessible, there's no doubt it's going to transform the way our children's generation will work, play, learn, and build. Huffington Post a couple weeks ago. Additive manufacturing technologies create a world of possibilities. Terry Wohlers, who's a world international consultant to manufacturing technology companies. 3D printing technology has already changing the world, but we haven't seen anything yet. Okay? So, when I started to read all this stuff, I finally figured out what this talk was about. And this talk is about additive manufacturing. Is it snake oil or is it salvation? I'll let you judge by the time we get done with this. To make sure that we're all on the same page, I'm going to do a small primer on additive manufacturing, because actually there's people in this room, I will guarantee you, who know more about this than I do. Guaranteed, okay? But on the possibility there's some people who aren't completely grounded in it, let's talk about what this thing is that we call additive manufacturing. The first notion of additive manufacturing is that it begins in digital space. Now, this is easy words to say, but I need you to understand that additive manufacturing begins with the fact that you have digital data to provide to your manufacturing process. Without digital data, you can't get started. And that is not a trivial question when you think that we've got 300 years worth of designing stuff that wasn't done digitally. Okay, so you need digital data. You can't additively manufacture without it. You've got to get whatever idea or parts you want to make into digital space. And there's really two ways to do that. Left-hand side, you can capture it. I'm sorry, Amy. Left-hand side, you can capture it with a scanner. Scanning technologies are amazing nowadays. Okay, I take an object, I can use a scanner, I can use CT technology, I can do all kinds of stuff, but I can actually take an object and I can grab the digital data that is about that design. And once I've got it, I've got it. Or alternatively, I can use a computer-aided design station and I can create a digital design from scratch. But one way or another, I have to have it to make additive manufacturing go. Once I have, now imagine for a second, I've got an object. I got this object right here. This cool object. So I've got a point cloud in space of this object digitally. There's another set of softwares that take that object in space and slices it. And the additive manufacturing process depends on the fact that we create those slices digitally so that we can manufacture the object in layers. I think of it this way. This is a 3D object. I've got the data about it. and I've now sliced it into layers. I sliced it into a set of sequential two-dimensional layers, one on top of the other, to build it up, okay? So what we do in additive manufacturing is we download those layers to a machine, and go ahead. We download those layers to a machine, and layer by layer, we recreate that object in physical space using a set of materials that match this digital design that we have delayered. You know, and somewhere along the way, I've got this Star Trek transporter thing in my head about how this happens. It's not that, but we go layer by layer and we build objects in a variety of materials using a variety of different binding techniques to make the object that we have just delayered in space digitally, okay? Kind of makes sense? I hope so. There's really, there's a multitude of ways that we go about this, but in the end, there's sort of three ways create these layers. One would be we would take liquid and we depose it layer by layer. Okay, and I guess the analogy I think of is, think of making a cake. And I'm squirting this viscous material called frosting, and I want to put a blue layer on and then a red layer and a green layer, and I go around and around. Eventually I build whatever I want frosted. So I can take a viscous material and I can depose it layer by layer according to the digital data that I've sliced previously. A second way I can do it is I can put down a bed of powder and I can melt selectively the particles in that layer that I want melted. And what I do is I melt the particles together that I want melted, and I melt them in such a way that they grab the particles underneath, so the two layers join each other. And then I can go on and put layer upon layer and build an object that way. Or the third way is I can use chemicals. I can use a print head, and I can put down a layer of powder, and out of that print head I can spray binding material that grabs those particles next to each other that I want grabbed, and it grabs the particles underneath so the layers hold together, and layer by layer I build the object up in space. So conceptually you go, seems pretty easy. And it's not easy, trust me, but it's not conceptually that difficult to grasp, okay? Digital data, slice it, download to a machine, layer by layer, build objects. This process is to be contrasted directly with what we would call subtractive manufacturing. So for years, the way we've made stuff is we've taken blocks of material and we've whittled them down to something smaller that looks and is the size and material and shape we want. Hundreds of years of subtractive processes, 10 to 15 active years of additive processes. Additive versus subtractive manufacturing. I wanted to be sure you had a mental image of the way that I perceive this contrast between subtractive and additive manufacturing, okay? So, subtractive manufacturing is this. Okay, that's subtractive, and additive manufacturing is this. Any of you who want to unbuckle your seatbelts now and get off the plane, this would be a good moment to do it, okay? I've been doing this a long time, and I clearly understand the differentiation between these two questions, subtractive and additive. I will tell you that additive manufacturing, at its core, destroys the basic paradigms that we've accepted as the constraints of manufacturing for all the years we've done it. I'll guarantee you that, and we're going to talk about that a bit as we go. We talk about additive manufacturing as if it is a singular thing. And in fact, it isn't a singular thing. It's a range of things. So I like drawing this continuum, and at one end, we have a company called Bits from Bytes, another company called MakerBot. For less than $2,000, those companies will ship you a kit. You can assemble it in your den, and 4 hours later, you can be making parts in your house. Okay? That is awesome. It's amazing. It's not what X1 does. Okay? If you think of this continuum sort of from home-based manufacturing to what I would call full-blown industrial systems, we are at the other end of the spectrum. So if you say to me, I want a $2,000 kit to make spatulas in my den, my answer is, I can't give you that, but I know guys who will, and they're great guys with great companies. On the other hand, if you want a machine that will produce parts that are 6 feet long and 4 feet wide and that are used by Caterpillar and Ford and Boeing and BMW, that's who we are. But I want to make sure you see this because, in fact, additive manufacturing is not a singular thing. It's a range of things that have become associated as a technology group. But people say all the time, well, additive is additive. And the answer is, not so much. It's a range, it's a continuum of things. These paradigms I keep talking about are where I want to focus today. And eventually, I'm going to talk to you about the cost implications of additive manufacturing and the jobs implication of manufacturing. So that's where I'm going to get to. But before we get there, I want to try to embed in your head a couple basic ideas. And there's 3 ideas I'm going to talk about on the next 2 slides. The first paradigm shift that additive manufacturing provides for us. If you look at the object on the right, and I've got one of these on my desk, look at the intricacy of that bowl. It's beautiful, and it really is. Think about going down the street. Think about your wife or your husband or your boss walked in and said, I need you to go make me one of these. Okay, think about how you would do that. The fact of the matter is that in additive manufacturing, because we're delayering 3-dimensional objects into 2-dimensional layers, complexity and simplicity become the same thing. Any 2-dimensional layer that I go to make in an additive process is no easier or harder to make than any other 2-dimensional layer. And I want to dwell there for a second because of the 3 or 4 most potent concepts about additive manufacturing, this is one of them. The cost of complexity and the cost of simplicity in additive manufacturing are the same. Go ahead, Ann. I actually have one of these watches. This is a product we make for a customer. And if I could show it to you, it's about this thick. And there are layer after layer of detail inside of this watch. There's interconnections and there's little fake gears. I mean, the watch doesn't work. Understand, it's a static object. But there's gears and there's interconnections. And we've made several of these for a variety of reasons for a customer. When I go to make this watch, and what I did was I took exactly the same watch and I created in digital space a solid model of exactly the same watch. So this one is solid all the way through. There's no detail on the inside. In an additive manufacturing process, which watch is more expensive to make? Hint, if you guessed the complex one, you're wrong. Okay? In an additive manufacturing process, the solid watch costs more to make because it uses more material. But because every layer within the design is done equally quickly with no more complexity, the cost of complexity in this case is lower than the cost of simplicity. Now, if you know much about making parts, okay, you kind of got to get your arms around this idea that the cost of complexity and the cost of simplicity become the same in additive manufacturing. That is an absolute paradigm breaker in terms of how and the way people go about manufacturing products. So one reason that additive manufacturing is disruptive and it's going to change the world is that simple statement that complexity and simplicity cost the same. This is why additive manufacturing becomes a disruptive technology. And while we're here, I'm going to bring up 2 more points that I'll return to at the very end. I'm not going to talk much more about them. But the first is that additive manufacturing, by its nature, means that anything you can design, you can make. Paradigm 2 that gets broken, okay? In subtractive manufacturing, we are constrained by the ability of our manufacturing process to make the part. I would really like it to look like this, but we can't make it that way. So we have design courses in colleges where we teach design for manufacturability, right? So we teach people, I know you want to make it that way, but you can't. So this is the way we're going to make it. We're going to make it in 4 separate pieces, because there's no way that I can get at the undercut on the inside to give that whatever design constraint there is. And the way I think of this is, what we say to our designers is, design a product. And they start designing and they think, but I can't make it that way, I can't make it that way. So they begin to take some of the value out of the design they want, and they start locking it in this box, because they can't get at it, right? So they say, okay, I'll do this, I really can't do that, so they put more value in this box and more value. And at the end of it, they've got a design, and they've got this box that's locked with this value in there that they can't get at. Additive manufacturing is like this key, and we put it in that box and we turn it. And what happens is, all of this additive value in the design stage just pops out. Now, I don't know how much is in there. I don't know if it's 13.7% of all the designs done last year by the automotive companies. I don't know. It's a big number, okay? Additive manufacturing unlocks the ability to make anything you can design. Look at all the objects that surround us and say, how did we make them? Why did we make things in 4 pieces and assemble them together? Why did we do that? We did it because we couldn't make it in 1 piece. And on and on and on it goes. So, point 1, simplicity and complexity. Point 2, you can now make anything you can design. You have no more constraints. Corollary point to that, right now in Pittsburgh, we've got a run of these going in our machines because a customer of ours ordered 40 of them. And what he wanted on the backside was the names of 40 different people and their birthdays. Okay? So in our build chamber, we're building 40 of these side by side that have 40 different names and 40 different birth dates on them. And the cost to have customized each of those was about 15 seconds at the design station for a guy to go, Jimmy Jones, da-da-da-da-da-da, and download. We talk about mass customization as something that we desire. You know, we think about our lean journey, and we think about optimization, and we think about mass customization and making exactly what we want when we want it. And we want to do that. And then we run square up against the constraints of the real manufacturing world, because that sort of customization is expensive. It's not in additive manufacturing. Mass customization is not only possible, but in fact, we do it every day. Another paradigm that gets broken. Okay, so important technology, very, very disruptive. I'm going to dwell some on this question of cost and ultimately of jobs, because as I said, that's where people really want to take this discussion. So let's talk about that for a minute. I hope that if you know anything about manufacturing, you would accept the premise that things that are low in complexity are inexpensive to make, and things that are high complexity are expensive to make, and that in fact that's not a linear curve. As things get complex, it's a geometric curve in terms of the cost that we have to endure in a subtractive manufacturing world. So I hope you'll accept this as a premise, and it's not metric, I mean it's just sort of a curve I drew, okay? So you think of the subtractive world as that curve. Now think of what I said about additive manufacturing, about complexity and cost. So that I won't get yelled at, because I make this flat and people say, no, but the 15 seconds of design, you have to put that in there. So, okay, so I put it in there. So I'm going to tilt this thing a little bit, okay? So it's not exactly flat, but it's tilted a little bit. So let's put both curves together. And in a true cost world, what this says to us is, since complexity and simplicity cost about the same, there is some point on the complexity curve where parts get complex enough that it makes sense to do them additively, right? You with me? This is a trap, so stay with me until the trap snaps, okay? So the question is, how complex does it get before additive makes sense? And some years ago, that was really complex because additive manufacturing was expensive to operate. I always tell people, the great news about additive manufacturing is that the cost of simplicity and complexity are the same. The bad news, the cost of simplicity is now the cost of complexity, okay? And that's not so good, okay? So we have this phenomena, but I hope you'll accept that there is a convergence point, and sort of everything to the right of that point would make sense to do additively, strictly from a cost perspective, right? Okay. I don't think it's so important to talk about where we are today. One of my favorite quotes is from Wayne Gretzky, who said, "I'm good because I don't go where the puck is, I go where the puck's going." Okay? So when I think about technologies, I try not to think about the static today condition, but let's talk about the tomorrow condition or the 1 year from now condition. What I will tell you is this, and this is the only plug I'll put in for X1 in this whole presentation, okay? In 2008, think about, the term is volume per unit time produced, okay? So we got a machine where we put down material and we've got a print head and we go across it and we spray binder and we print volume per unit time. In 2008, on average across the machines we were building, we were producing 17 cubic inches per minute of material. A machine we're going to show in Chicago in September at the Machine Tool Show, we're producing 167 cubic inches a minute. That's a 10 times increase in 4 years in cubic volume produced per unit time. So what does that do to the curve we talked about a minute ago? Well, obviously, it shifts the curve down. Obviously, the conversion points moves in. Obviously, now to the right of that convergence point, we've created a whole new set of opportunities, strictly from a cost perspective, to say additive manufacturing makes sense. And I guess the other point I would make is we've been trying to optimize this subtractive manufacturing curve for 300 years. It's not that the curve's not going to move. It's going to go lower. It should. There's a lot of great companies in the world that build machine tools that have spindles that can now go 120,000 RPMs instead of 10,000 RPMs, and linear motors that go faster. So in a subtractive world, we can actually move this down. We can get super Martian moon rock coated tools that whatever. So, you know, there's room here to go. Is it a couple % a year? Maybe. But what happens to this graph if this curve moves 3% a year and this curve moves 30% a year? What does that say about the future of additive manufacturing on a strictly a cost basis alone? I think it's fairly obvious, okay? So that's about the cost size. And in fact, Terry Wohlers, is again this industry expert, the simple fact is that in today's world, we're talking about an industry itself which will be $5 billion by the end of 2020. That's the manufacturing technology sales, not the producer sales using additive manufacturing for parts. So if Caterpillar uses our process to make a transmission housing, that's not counted in the number. That's just the equipment sales. So it's a rapidly expanding industry. So what I've hopefully done is embedded the notion in your head that additive manufacturing has the potential on a cost basis to be significantly more cost competitive as time goes on. I'm asked a lot about, well, what about jobs? Because the fact of the matter is that when you run an additive manufacturing facility, you're not going to need the number of people that we used to have. And that's true. That absolutely is true. Not only are we not going to need the number of people that we used to use, but the skill sets that those people are going to employ are going to be different. So a technician on our shop floor is no longer a craftsman. He no longer understands, and you know, I've run a lot of machine shops, okay? I mean, I know guys who would say to me, the only way to get the tolerance on that part on this lathe is I heat up a towel and I wrap it around the spindle bearings, because on that part, that allows me to make sure that that spindle bearing works in a way that I can get that little chamfer I need on the inside. It's the only way to do it. And that guy was worth $1 million, right? I mean, he could do something with that machine nobody else could. He was a craftsman. In additive manufacturing, the craftsmanship is in the system and the process that we provide, not in the ability to make the machine do something it couldn't otherwise do. So the job's going to be different? Absolutely. No doubt about it. Are we going to employ people who understand the digital world, who are system managers, I mean, whose job it is to make sure that this very intricate additive manufacturing system we produce works? Absolutely. So, is that somehow indicting that says we shouldn't pursue an additive manufacturing path? Well, I guess I've got two answers to that. The first is, and it is a well-known fact, that there is a multiplier effect when you add a manufacturing job in a region. Because not only do you have the shop floor job, and in the case of additive manufacturing, the designer and you know, the HR person and the finance person, everybody else you need in your company to make it go. But then think about, well, whose truck picks it up at the back door? Where does the material supply come from? Where do they eat lunch? You go right down the list, and there is, in fact, the recent NAM study that just came out says there's about a 1.4 times multiplier for every dollar of manufacturing you do. You get another $1.40 in other economic activity that surrounds that dollar of manufacturing. So, does it make sense when we say, but additive manufacturing doesn't create the same kind of jobs we had and not as many of them? Does it make sense? Well, what I would say to you, if you say to me, no, it doesn't make sense, what I would say to you is simple, okay? There were dynamic forces that drove American manufacturing jobs offshore. Those forces have not changed. So you can argue that exchange rates are going to shift, and you can argue that, well, but China's middle class is coming up, so Chinese wages are getting higher. Folks, those changes, which are interesting, are not going to be enough to propel manufacturing jobs back onshore in and of themselves. It simply isn't going to happen. It's not going to happen until we break the paradigm that we have in the existing manufacturing world and we provide a new paradigm. With a new paradigm, the location of jobs becomes a whole new subject. It's a white piece of paper to talk about again. And I will tell you actually kind of an interesting story, and this is 2 weeks ago story. We have a place down in Houston where we support the oil industry. We do a lot of work with oil energy supply companies. And one of our good customers down there needed 9 castings. So on a Monday he called and said, I need molds for 9 big housings. No problem. So we made the molds. Thursday morning we shipped the molds, so we filled the order in 3 days. This normally would have taken 12 weeks, but 3 days later we shipped molds to him so he could do his casting in his foundry. 4 o'clock in the afternoon he called. I got a problem. We got 8 molds off the truck. The 9th mold, the fork truck driver dropped the mold, shattered it. And I've got to cast my 9th part. I need 9, I don't need 8. So this is 4 o'clock. He's called our plant manager and he said, can I talk to you about how we can go about getting the replacement? I'll give you a call at 8 tomorrow morning. Our plant manager walked out, went to the machine, downloaded the file that he needed, and hit print. He went home. Guy got up at 5 o'clock in the morning, went in, the mold was printed, he dusted it off, he put it on a pallet, he put it on the back of a truck. 2 hours later, 8 o'clock in the morning, he arrived at our customer's back dock. The plant manager from the customer called and said, I want to talk to you about how we're going to get the replacement mold. And my plant manager said, go to your shipping dock. It's there. So the last paradigm I want to talk to you about is this notion of locality versus globality. If somebody says to you, we want additive manufacturing to be present in our world, but we want to do it 5,000 miles away, don't do it, okay? Because the value of additive manufacturing is that we can provide precisely what we want, when we want it, where we want it, in a local basis. You destroy the value of a system that can give you one-day turnaround when you say, oh, by the way, I got to put it on a ship and bring it across the ocean. So why is this important? Let's just kind of review what I view as the key points of all this. So if you want the takeaways are on this list. Actually, not on that list. If we flip it, thanks. There we go. So why is additive manufacturing important in the US? Cost of complexity equals the cost of simplicity. So if you want one to walk away with, there's one for you to try to get your head around, okay? There is a tremendous opportunity to keep optimizing and driving down the unit cost of additive manufacturing. Any design that you can make in digital space, we can make in a part. We can unlock for the first time this value in design that we've been giving away because we say we compromise. And finally, the multiplier effect is tremendous. So do I think, for the sake of my 4 kids and my 7-year-old grandson and my 1-year-old grandson and my, in November, next grandchild, do I think this is important? I'm passionate about how important I think this is. Additive manufacturing breaks the paradigms that we have faced for hundreds of years in manufacturing. It provides the window, the opportunity to bring manufacturing back onshore in this country. Is it going to happen? Will additive manufacturing collapse under the weight of expectations as so many other technologies have? I don't know. I mean, I'm not smart enough to know the answer to that question. But what I do know is we're right on the doorstep. And whether we embrace it or don't embrace it is going to say a lot about where we go in the manufacturing world coming up over the next 10 or 20 years. So, in answer to the original question I asked, which is this question of, do I think this is snake oil? Do I think it's salvation? Drum roll, please. I think you know my answer to the question. Okay? So, thank you very much for being attentive, and I'm happy to answer questions.
Okay, we'll bring this around, okay? And make sure to mention your name first.
Peter Gourlay with RMI. Question for you in terms of how do you think the U.S. stacks up with global competition as it relates to additive manufacturing? What's the window of opportunity?
That is a great question. I'm not an authority on the subject, but I'll give you my best answer. There is very little initiation of additive manufacturing activity going on in Asia. We have some European companies that are really active, but they tend to be focused in the space that supports very, very high precision and probably lower volumetric output applications because of the approach they're taking. In the US, we seem to be more focused on how do we increase volumetric output to really become competitive on a unit cost basis. So we are ahead. And I think we'll stay there. One reason we're ahead, by the way, is because the enabling technologies that make this go, the digitization technologies, the data capture technologies, and creation technologies, and the software technologies, most of that resides here. So we've got a natural advantage, and it's an exploitable advantage. But of course, you know, if somebody invests enough money, they can close that gap. So we just got to. One of the things I actually tell the folks at our company is, you know, I've driven in Germany a lot on the Autobahn. And I tell people in my company, when you're driving on the Autobahn, the only time you need to worry about what's behind you is if you're not the fastest car on the road. When you're going the fastest, doesn't matter what's going on to your right or in back of you, all you got to do is worry about what's in front of you. So our job is to be the fastest. The minute we slow down, we got to start worrying about what's coming up behind us. So, yes, sir.
Hi, great talk, and I'm psyched to be
Thank you.
here. My name's Ron Kelly. I'm with Green Gap Solutions. I'm a small business entrepreneur. I've used 3D sort of SLAs for years for prototyping and such, so I'm real excited to see this moving into mainstream. But I've also, as part of my business, so this is I think this is an opportunity. So it's a statement or a question. So, and I've read an article recently because I'm very much into doing life cycle assessment, energy, carbon footprint, things like that. And I was surprised to see an analysis by a pretty well-known person that looked at, I think they were looking at making parts by additive manufacturing, probably it was plastic, and I think it was more a melt style. But in general, it was stating that the cost of the amount of material used was significantly higher, which surprised me, and I think you would probably, and I want to hear what you would say about that. But the thing that really shocked me was the indication that the amount of energy that was being used to make a part was like 10x that of a conventional, like a molding process or something. I see it as an opportunity in this country because of the low cost of energy going forward. That's what I'm really excited about. That's the last part. But I'd like your comment on the use of energy in this process. Thanks.
Well, the question is about, specifically about energy costs and material costs in the process. I would strongly argue the material amount and cost question. The fact of the matter is that when we print a bed of powder, when we're done printing, all of the powder that we don't print, we reuse. So we only use precisely the amount of material we need. And so the question then is, well, how does that compare with what you would do subtractively, where you're producing chips and a bunch of other things? The answer is, I think it's obvious, but maybe it's not. On the energy side, I think it depends on the process. If you're using an electron beam, it's possible you're using a lot of energy. When you're using a print head, I again would argue, I have lots of data available that says that simply isn't true. But but let's say it's even equal. The rest of the story is so compelling that from my perspective, if energy costs were equal, then it's an easy answer. So, yes, ma'am.
Hi, my name is Susie Gans. I have a quick question for you. Question is, if you look at the next generation, the next 7 years, let's suggest, with regard to additive manufacturing, does the technology drive material science, or does the material science, in terms of the next generation of material science, drive the additive technology?
Yes and yes.
Can you comment on that when you're talking about things like building hearts or building,
Sure.
things that
Absolutely.
are far more complicated?
Because I came from the machine tool world, we used to have this exact same debate between tools and machines. Because tool technology would leap ahead, we'd come up with a carbide coating, and the machine couldn't go fast enough to use it. So the machine would improve, and then suddenly the machine could do more than the tool could, so the tool technology would leap ahead. So I guess I kind of understand the nature of your question. I will tell you that we have been involved and are actively involved in a variety of biological work we're in Pittsburgh, so UPMC is of course there. We're active up at Mass General. We have printed biological materials that have been used in liver research and in lung research. We have printed bone scaffolds. So the yes and yes was kind of a smart guy response, but the fact of the matter is that they're going to tug each other along. What we need is better material science research that begins to say, can you print this material? Then we need to go to our machines and say, how do we make the machines print that material? But clearly, in the biological sciences world, additive manufacturing is going to be immensely important as we go, immensely important. I mean, in today's world, if you get a knee replacement, it is likely being done additively. I would guess that more than 50% of all hip and knee replacements, the doctor goes in, he says, this is the design I need, he goes out to a laser sintering machine, gets titanium, and he prints it. The biological stuff is really interesting because what we're discovering is we can print these inert materials and we can inject live cells, and those live cells grow and they displace the inert materials, and suddenly you have a functioning organ. We're not that far away, truly. And it's going on in lots of different places. So, yes, sir.
Great talk, Jake. I'm John Danko at Danko Arlington. I have a comment to make about the premise of rapid prototyping versus the complexity versus the simplicity. The premise is that they're small in size. I'd like you to comment to the audience about large parts. As a manufacturer, we have constraints in what we can print and what we cannot due to the size and also the cost. So if you could
Sure.
kind of clarify, it would be great to see a slide that has cost, size right now in additive manufacturing.
If I understand the nature of your question, the discussion about additive manufacturing, the conversation going on in the country has largely been focused on the small end. And yet, our largest build platform, we make objects today that are 6 feet high and 4 feet wide by 4 feet. That's what we do. And in fact, in the mold world, where we print molds for castings, we have cast a 96-inch impeller using segmented molds that we bolted together. So in our world, size is not a constraint at all. In fact, we don't do very many little things. We do a variety of big things. Generally speaking, we equate size and complexity to some extent. So as things get big, they tend to get more complex to make. And that's absolutely where additive manufacturing has shined in the past, because once we get into bigger sizes, it really becomes obvious how effective the process is. You know, when you're dealing with a metal object about this big, sometimes it's not as easy to see it. When you get to an impeller that's going into a pump that's 8 feet across, it kind of is easy to see it. So, is that the nature of your question, or did I miss
Well,
it?
I just see that larger parts require more material and a larger machine, and there's a great deal more cost involved in manufacturing something the size of that table behind you, for example, in additive manufacturing versus making it conventionally. And where in the future is this technology going to go 10 years from now? Is this going to be, we can do something that big, we can print chairs, we can print tables, we can make them easier than by hand or by other methods?
Well, it's an interesting question, and not one that's easy to prognosticate. What I will say this, and so to give you some flavor of how this stuff works, we built a service center down in Houston for one specific reason. In the oil field, in refineries, they've got a lot of old equipment that breaks a lot. And when it breaks, a lot of times it's 30 years old, and the guy who made it in the first place isn't there anymore. The drawings for what it is aren't there anymore, and yet a refinery's down because something's down. So the oil field service business is a big business down south. And generally speaking, if a housing for a pump cracked, what would happen is they would find a service provider who would say, 14 to 16 weeks, we'll get you new housing. Very routine, okay? Because we'd have to find a drawing or dig a drawing, we got to make a pattern, we got to do the casting, we got to machine the casting, so 14 to 16 weeks. Today, routinely, and this is not, I love it because the end customers kind of say it was magic, but routinely, this is the way the process works. We've got a customer in Houston who has tremendous reverse engineering capabilities. He gets broken components and he goes down and he reverse engineers them. It takes him 24 to 36 hours to actually get the data scan of what he wants. He downloads that scan to us. Within 4 hours, generally, we are printing the sand molds. Within a day, we're delivering the sand molds, and a day later, he's casting. So that industry went from the service end providing 14 to 16 week lead times to 4 to 6 days in one fell swoop. How do you quantify that? I don't know. What's that worth to the refinery? I don't know. What I do know, though, is that's the power of this, and when people say, my God, it's almost magic, you reduce lead time so much, we say thank you very much, and we say to each other, we couldn't take longer if we wanted to, because that's sort of what the process does, you know. So hopefully it partially answers your question. We are rooted as a company at the big end of things, and so that's what I think and kind of talk about. Yes, sir.
Hi, Michael Taylor. I'm an entrepreneur. I was just wondering, when personal 3D printers become cheaper and more mainstream, how is that going to affect the multiplier effect that you were discussing, when you can just print out your house instead of going to Walmart?
That's a good and interesting question. There is a core group of people who believe that it's time for the democratization of manufacturing, that we should create a digital highway that houses designs and material sets, and everybody should have printers, and what you should be able to do on a Friday night if you want to is go to the digital highway, grab a design, download it, and make it for yourself. First off, there's some questions in all of that. There was this guy who started this company called Napster, who sort of thought the same thing, and how'd that work out? But how real is that? I don't know. There's a lower end cost constraint to just get the mechanism itself, and I don't know if it's going to stay at $800 or $900, but it's probably not going to get to $99.95. And secondarily, of course, then you have to have the materials that you want to use, and the materials have to be useful in your home. And if you really want to do things like metals, you got to have a machine that's capable of much higher temperatures than the home systems we have today for plastics. But having said all that, we're in one of these curves here, and we're in the increasing rate of improvement and new ideas. So where it's all going to go, I'm not exactly sure. What I am sure of is 5 to 10 years from now, it's going to be far more practical than it is today. Do I see a day where you need a new muffler for your car, so you're going to go out and hit print in your garage and a muffler is going to come out? Probably not. But for a whole range of really easily customizable kind of home stuff, yeah, you want a spatula with your kid's name on it? We can do that in a minute. So.
You know, Dave, these newfangled things really get in the way of the way we like to enjoy ourselves. I'm sure in the 1890s, people were saying something about that light thing, that car thing, the phonograph thing, and told us all the reasons why those things aren't going to work. So one of the nice things about hanging out with pioneers and visionaries is we don't let those things bother us. We see the essence of what this is all about and understand it. It's the right thing. I'd like to ask a question. I'd like for the students, people that are students at the university, you just kind of stand up. I want to see who's in. I know we have some students here today. Do we have any? Okay, don't be bashful, students. This is your moment. And also, I want to mention Ben Palmer is a student who's from Towson University, from the film department, who's videoing us. Is there? I know you're bashful. Is there any questions that you would like to ask Dave? It's your chance. Okay, good.
My kids are great, thank you. Was that the question?
Yeah. Oh. Yeah. Kids are great. They're the ones that are going to make manufacturing happen. That's why I wanted to.
I'm Vince Domino. The question I have is, now that we have all these technologies, these printers are even like in high schools as well. What's going to happen when we have so many students that are now graduating that have the technology, the education to work, but there's a bottleneck for jobs? Like there's only one technician for one printer. Now you have 5 people that are available to actually work it. What's going to happen when that problem arises?
Well, that presumes that problem will arise.
Yeah.
And I'm not entirely convinced. I don't want to be dismissive of the question because it's a really important question. But I don't want to accept as an operating premise that that's going to be a constraint. What I will tell you today is that when we decide to go out and hire a designer who understands both digitally based manufacturing processes and CAD design, we look for weeks and weeks and weeks, and we can't find them. And we're only a singular company. But I guess my question would be, what would happen if the hundreds of billions of dollars worth of industrial production that we talk about was converted to an additive style? How many designers would be required to support that kind of base? It's a really big number. So I wouldn't, at this juncture, worry about that a whole lot. I really do think there's going to be a myriad of opportunities to go in all kinds of different directions. And partially, I'd say to you, what's your next best alternative? If not this, then what? And from my perspective, there really isn't a choice. This is the way to go. But I will tell you today that companies like ours that are interested in this, we can't find enough qualified people. And part of the reason is because it's this notion of digital natives and digital immigrants. I'm a digital immigrant. I wasn't born into the digital age. So talking about this stuff is really great, and I don't get most of it.
Okay. We probably have time for one more question.
But you're a digital native. this is intuitive to you in ways that it'll never be intuitive to me. So the day that you're a general manager of a facility, the world is going to be just put on its ear in a lot of ways. So, okay, I'm sorry. Yes, sir.
Jamie Sheridan, Maryland Institute College of Art. I teach students like that. Make the following assumption that the real question is who can do what? And in a digital world, who can do what where becomes highly flexible. So it's the access to material size and resolution becomes the question. So when someone wants to print a house, not print in the house, right?
Yes.
Which is perfectly possible now. The real question is model validation. How do we get it so that my students who do these brilliant designs but come up with models that may or may not be valid, how do they get their model, forget the funding for the moment, to the guy who has the house printer? Because once that becomes possible, what you have is a reorganization of the job structure. What used to be a direct hiring actually becomes, in essence, an entrepreneurial act as people build their own houses. Now, small scale, there's a lot to say for small scale, but you see where I'm going.
Sure.
What is the bottleneck? And my question is about model validation, particularly if you've had experience with this. What kinds of problems arise when designers send you things that's coming out of SolidWorks? And then you have to actually actualize that.
Which we do.
Yes.
We have a front-end filtration process that we put all models through before we try to print them. And we've got a cadre of people who, many of whom look like these students, who work all day long with an understanding of the technology and the design science and can say, yep, we can do that, or no, we can't. I would assume every additive company has the same sort of filtration system. So I don't see that as an issue because every technology's got its boundaries, and if you understand the boundaries, you filter.
Can that filter be roboticized?
To some extent. We do today. We run files through certain parameters, and when we get a flag, we go in and look at it and say, can we or can't we? So, and by the way, there are 2 companies in the world I'm aware of today that are printing houses out of viscous, concrete style materials. So, yeah, it's possible. Okay, folks, I've been up here way too long.
Oh, okay. All right. Very good. Let's give Dave a big applause. We have